Namaste, and welcome you all to today's discussion. Today I will talk about reinforced concrete road bridges. Concrete is one of the most widely used materials in construction. It is economical, durable, and can be molded into any shape. But concrete has one big weakness. It is strong in compression, but very weak in tension. If we use plain concrete alone, the deck will crack under load, so engineers embed steel bars inside the concrete. Steel is strong in tension, so it handles the pulling forces. Concrete handles the compression forces. Together, they form what we call reinforced concrete, or RC. Now let us see why reinforcement is needed. When traffic loads a bridge deck, the deck bends. The top of the deck goes into compression. Concrete handles this zone very well on its own. The bottom of the deck goes into tension. Concrete is weak here, so steel bars are placed at the bottom. This can be pictured using a T-shaped cross-section. The top flange lies in compression made of plain concrete. The bottom web lies in tension, where steel bars sit. Let us look at the key features of RC bridges. First, they offer high strength and long durability. They can serve for 50 to 100 years. Second, they resist fire and corrosion very well. Third, they need very low maintenance over time. Fourth, they are highly economical to build. This makes RC bridges the most common choice worldwide. Now let us move to the types of RC bridges. There are four main types based on deck shape. These are solid slab, T-beam and slab, box girder, and continuous bridges. The first type is the solid slab bridge. This is the simplest form of an RC bridge. The deck is one solid, uniform slab of concrete. It suits very short spans, up to 8 to 10 meters. It is mostly used for small culverts and minor bridges. Its advantage is simple design and easy construction, but for longer spans, the slab becomes too thick and heavy. The second type is the T-beam and slab bridge. Here, the deck is cast in a T-shape. A thin top slab sits over deep beams called T-beams. Cross girders give stability across the width. This design suits medium spans, 10 to 25 meters. It is the most common bridge type on highways today. It saves material compared to a solid slab, but it needs more complex formwork and skilled labor. The third type is the box girder bridge. Here, the main structure is a hollow concrete box. This hollow shape gives very high torsional rigidity. It strongly resists twisting forces during loading. This suits eccentric loads and curved alignments. It suits longer spans, above 25 meters, up to 50. It works well for flyovers and heavy traffic. It also gives a sleek, modern appearance, but it is more complex and costly to build. The fourth type is the continuous bridge. Here, the deck runs over 3 or more piers. There are no expansion joints breaking up the spans. It behaves as one single structural unit. The bending moment gets redistributed across supports, so the maximum bending moment becomes lower overall. This allows a thinner and lighter deck. It also gives a smoother ride for traffic, but it needs very strong foundations at every pier. Even slight settlement can create serious stresses. It suits long river crossings and elevated highways. To summarize, RC bridges combine concrete and steel effectively. Concrete handles compression, and steel handles tension. Solid slabs suit small spans and culverts. T-beam and slab bridges suit medium highway spans. Box girders suit long spans and curved bridges. Continuous bridges suit long crossings with strong foundations. Each type balances span length, cost and complexity. Thank you.